Hi everybody! Suppose you are competing in a game show. The show host says, behind one of these three doors is a car, whereas behind each of the other two is a goat. If you pick the right door, you can win the car. Which door will you pick? Since you don't know any reason to prefer any door, you can pick any one of these doors, right? Suppose you picked door number 1. The game show host says, I'm going to give you another chance. I know which of these three doors hides the car, and to help you, out of the remaining two doors, I'm going to open one door which hides a goat. Here's your chance again. Will you stick to the door number 1 or will you switch to door number 2? Remember, you can never be sure as to which door hides the car, but you must pick the door that has a greater chance of hiding the car behind it. So think carefully. So what did you decide? Did you think switching gave you a greater chance of winning or sticking? If you thought you had an equal chance of winning, regardless of whether you stick or switch, I'm afraid you're wrong. Here's why. When you pick the first door or any door, the chance of winning the car is the same, that is 1 out of 3. Therefore, the combined chance of the remaining two doors is 2 out of 3. But the host's action gives you extra information, so watch carefully. Remember, the host is not allowed to open door number 1, which is the one that you picked. Therefore, the host cannot tell you anything about door number 1. Between doors 2 and 3, the host deliberately picks a door that hides a goat. In this case, he picks door 3. Therefore, door 3 is not randomly chosen, unless both doors 2 and 3 hide the goats. But as we've seen already, chances of that happening are rather small, only 1 out of 3. Now that door 3 is open, we can see it has 0 chance of hiding the car. But the combined chance of doors 2 and 3 is still 2 out of 3. Therefore, the chance of door 2 must increase to 2 out of 3. Therefore, you have a much greater chance of winning by switching to another door than by sticking to the original door. Notice, this does not mean that you will always win by switching, but that if you play this game again and again, such that the car is placed randomly each time behind any door, then by switching, you will win 2 out of 3 times on average. Perhaps you are still not convinced and think that the chances of winning must be 50-50 between doors 1 and 2. If that is so, you are not alone. So here's another explanation. Suppose the car is behind door 1, which is the one that you picked. Now the host will open either door 2 or door 3. Regardless of which door he opens, if you switch, you lose. However, the second possibility is that the car is behind door 2. In this case, the host can only open door 3. Now if you switch, you win. The third and the last possibility is that the car is behind door 3. In this case, the host can only open door 2, and again if you switch, you win. Therefore, in 2 out of 3 possibilities, if you switch, you win. Hence, switching gives you a greater chance of winning. This problem is called the Monty Hall Problem. It is a probability puzzle and has even been part of a movie called 21. The problem itself was published in 1990, but most of the readers, including 1,000 PhDs, refused to accept it. So if you do not understand it, you are an elite company. It is nevertheless true and is in fact a paradox. So if you have understood it, well done to you. You can also easily play this game with a friend and prove it to yourself that the solution works. Thanks for watching, and feel free to share it with your friends and test them out.